So, in previous years, what we've done is installed Anaconda via PyEnv or had it installed sort of directly in the labs. We're not going to do that this year. Instead, we're going to use UV, as we've talked about previously. The main reason is that Anaconda is very large, can get very inflexible, and eventually you'll just sort of replicate what UV does with VMs because you'll have to start using your own virtual env, adding particular versions and everything else to do it. So VM has a whole sort of section in the documentation here on tools. That's not the one I'm looking for. On how to use Anaconda. I will find the link. I can't find it here at the moment. It's in here. So what we'll do is we'll sort of go through these different elements of how to set it up and use it. And again, I've got ways of here we go, it's in the integration section here. I've got ways of sort of setting things up to work with Jupyter, as you can see here, and in particular with PyTorch, which is our main machine learning things. There are templates already set up to get this to work, and more importantly, work cross-platform. So one of the main things is, Anaconda can get big. I've seen it get up to 15 gigabytes. UV only uses what's needed. It's really quick because of the caching and the way it works. Reproducibility. This is what we want. We want PyProject TOML, UV lock, run UV sync. It'll go, right, those are all the versions. They all work together. I'll use those. So it's using a standard PyProject TOML, not the Conda stuff that it does. It all gets sort of messed up and so on. And so it allows us to just sort of work more efficiently once you get used to it. Now, at its simplest level, we can do something along the lines of this. So what I'm going to do, again, I'm on my desktop at the moment. What this is going to do, and again, it'll be slow to start with because I've not run this the first time. What we're going to do is we're going to run UV run using the -- with flag. So -- with says I want to run with a package. In this case, the package is Jupyter. And then the program we want to run is Jupyter Lab. So again, it looks complex to start with, but what this is going to do is it's going to, sorry, wrong paste command. What it's going to do is create an isolated sandbox, run a Jupyter server for us, and then run Jupyter Lab. And what that's going to do, as you can see, first time running, there's a lot of packages there that it's got to download, because this is all the stuff that base Jupyter needs. This is what comes with Anaconda by default, but next time we run something, this is already going to be installed for this particular version of Python. Therefore, it's going to be relatively fast compared to this first time that we run it. Once this is installed, everything, so 97 packages, it's installed. It should now run Jupyter Lab once it's ready. And open up a web browser for us. There we go. So now it's starting up the Jupyter server, starting up all the notebooks and things like that. Obviously, again, it's one of those first time things. It's a little slow. And then here is basically the Jupyter you know. So at the moment, what it doesn't have, so I can come in here and create a new notebook. And we can go in here and it's got a basic kernel in there, and I can print hello from Jupyter like that. Oops, wrong button. Close bracket, and then I can run that cell, and that's working. And you can add new cells and replicate things and things like that. One thing it doesn't have is all of the default packages. And the reason for that is because we've just run this in an isolated sandbox. This is just running Jupyter Lab. It's fine for simple bits and pieces like this. What it doesn't have is a lot of the core base packages that you just take for granted. And so there is a little extra work that we need to do when we want to run this. Now, it is possible So Control C to shut down the server. This is basically a read-only project. If we need additional packages and we want to create projects that work in a different way, we need to basically add a few extra bits and pieces when we're running it. And basically it's recommended that we create a default dedicated kernel. That means when we run things, we can install the IPy kernel as a development dependency, and then we can go through and add other bits and pieces like that. So if we were to start a brand new project, so again I'm on my desktop here. What I'm going to do is I'm going to type uv init, and what I'm going to do here, you'll notice here I've got the --bear flag, and what --bear does is it doesn't add anything but a pyproject.toml. And the reason why I'm doing that is we don't, so if you look here, that's all that's there. We don't need main.py because we're going to be creating notebooks. We don't need Git necessarily because Git doesn't always work nicely with notebooks and things like that. So it's one of those things that a lot of the time you just want an empty project to get working with. Next thing we need to do is we need to seed our kernel in here. And again, there are different ways of doing this if you read the notes. The simplest way is to just add a development kernel here. So if I go through in here, and again, so what we're going to do is uv add --dev. So all dev does, as you can see here, --dev, is it adds it to the development section of the pyproject.toml. So if I put this in here now, like that, oops, missed the space there. Now you can see it's adding more stuff in here. It's creating that for us. We've got our own isolated standalone pyproject.toml here now, setting it all up, adding all the tools that we need. Again, takes a little while first time round, but now it's here. If we have a look at the pyproject.toml now, oops, you can see that we've got a dependency group now of dev. Nothing here still in the dependencies. So what we'll do is let's just open up the pyproject.toml file and keep an eye on that. What I'm now going to do is uv run with Jupyter Lab to fire up Jupyter Labs. So that will open up my web browser. And we're in again, so now we're in a dedicated kernel. We're in our own version here, and what we can do is, you can see we've got pyproject.toml and our uvlock file here. What I can do is create a new notebook. Now, if you're used to doing standard pip magic in your projects here to install your dependencies and things like that, we can do exactly the same. But now what we can do is we can use uv instead of pip. So if we do !uv add numpy like that and run that, you can see that it's going through. Now notice it is giving a warning here because it's found a different one. You can get rid of that to say target the active. It's just a UV warning. So what we can do is in here is we can say uvav --active like that, and if we run it again you can see it's just added the packages there. That's just part of how it works, but we've added that. So again, uv add --active, say if we want pandas, that will go off and add those packages there. So basically we can, as we would do with a normal magic in pip, we can do exactly the same there. And what you'll notice is that they've been added to the pyproject.toml directly in here. So now when we go back, we can delete the VM again, we can recreate it next time we run Jupyter via UV. And again, just to sort of demonstrate that, if we had a new, whoops, wrong cell, I want to do one below, come here. If we add a new cell there, we can now say import numpy as mp, and then we can say mp dot, I think it's done version in that case, and that should run. There we got numpy 2.3.1. So that's working fine. It creates a great little project for us. Now, obviously, in this case, we're using Magic, as we would with pip, to install stuff before we run it. Obviously, we can ship with a PyProject.toml instead and have everything that we want in advance. Now, some of these can get quite complex, and in the next lecture, what I'll do is I will demonstrate a basic machine learning with PyTorch example. I will also demonstrate a few other bits and pieces with DirEnv to basically add some magic here so that we can make it work with these. So we literally type JupyterLag, JupyterQt console, or Jupyter Notebook. I've only enabled these ones, but there are more that we can do. So I'll demonstrate that in the next lecture using the PyProject here.